In this video, we are going to learn about the derivations of the three formulas which are used in the kinematics, that's acceleration, displacement and v square minus u square. Hi friends, today we are going to derive the formula of used in the kinematics 1D. There are three main formulas to derive, that's acceleration, displacement and v square minus u square is equals to 2as. These are the three formulas those we are doing, but the third formula is needed because of lack of t or presence of t in both equations. When you see the equation 1 or formula 1, here also it's t is it, and in the displacement equation 2, here also t itself is available, but this third equation needs, it's an equation without t to find like acceleration, displacement, initial velocity or final velocity. This equation helps us to find these values without t. So let's get started by solving the equations, and now let's get started for the formula 1. Before that, let's see some important terms which we have read in the last class. Here, when this car, it was initially here, this is this u, initially it was having some velocity, that is u, and finally at the end when it stopped, it was having certain velocity, that's v, and time taken to travel from this point to this point is t. Time taken is t, and the displacement from this point to this point is denoted by s. These are the main or common terms which are used in this deriving formula. And other term is acceleration. It means rate of change of velocity, that we are going to see here. First one, in the equation 1, to find this equation 1, it's just we can do it with the definition of acceleration, that's the rate of change of velocity with respect to time. It means a is equals to rate of change of velocity. Rate of change of means we use delta in the physics. Delta means rate of change of anything. Rate of change of anything is denoted by delta in the physics, but when you go to the maths, it shows like area of triangle, or in the different subject delta is shown as different way. In the physics, delta means rate of change of. Delta gives the value rate of change of. Here delta v by delta t, this we can write as v minus u by t. A is equals to v minus u by t. If we want final velocity, we can do just some simple calculations, that we get v is equals to u plus at. Here these both will be multiplied, it becomes at, and when you send u this side, it becomes u plus v is equals to u plus at is equals to v. This is the formula 1. This formula is also used in deriving the third equation. Now let's go and solve the second equation. This equation is s is equals to ut plus half at squared. This is the equation which we are going to derive now. Here, when that car started to move, it was having certain velocity u, and here time was 0. There was no time when it started. Time was 0, so we take u, this is the origin, or this y-axis we take as time, and x-axis, this x-axis we take as time, and y-axis as velocity. x-axis is velocity and y-axis is time. Here time was 0 when it started, so this is u. Here it's u, and after some point it reached its final velocity, that's v, with regarding to some time. Here time has changed. This is the graph of that equation, or this is u and this is v, and this is the time taken to reach from here to here. To find the displacement, we need to just to do this is calculation. We just need to calculate this. Here if we calculate the area of this part, we get the displacement formula when we do area of this part. If you see correctly or observed here, you can divide this part into two parts, one as triangle and one as rectangle. This is easy when you try to solve it. And from here to here, this part is u. This part is u, that's initial velocity, as you can see here, and this whole part is v, that's final velocity. And this sum part is where you see here v is equals to u plus at, where v is equals to u plus at. We know here v it is and u it is. What is here? If we add u plus at, we get v. When we add u plus at, we get v. So this part is at. This part is acceleration into time. Here u plus at is equals to v. Now let's derive the formula. Here S is equals to area of triangle plus area of rectangle. Here area of triangle is half into base into height. You know that area of triangle is half into base into height. Here half into, here base, for this triangle base is t, base into height. Here this is the height, at is the height, half into base into height plus area of rectangle. Area of rectangle means opposite or length into breadth. Here length u into t, u into t. So finally we get the formula S is equals to ut plus half a t square. This is the formula derivation of this equation. S is equals to ut plus half at squared. Next, now let's solve this equation 3. I have already told why should we solve the equation 3. It's because of both formulas are dependent on time. In this formula we are not going to use the time. For this formula itself we need the same graph. Let's draw the graph once. Here we have got the graph, so let's solve this. Here this formula is v square minus u square is equals to 2as. Here we don't need any much formulas or something. We just need to do is we take this equation, we take this v is equals to u plus at, we take like t is equals to v minus u by a. Can we write this equation? A is equals to v minus u by t. Yes, we can write a is equals to v minus u by t as t is equals to v minus u by a. We are going to take this formula and substitute in this equation, or we are going to do that, so we get the answer. Next, here it's of same graph. We are gonna take same graph. That's here it was initially u, and this is the base t, and until here it was initial velocity, and this is final velocity. This is u, at, and this is v. If you watch complete video, you can get how this v, u, a, t, v final velocity, initial velocity, this a, t, u and v got from this. We got these all from the last graph. Now here, instead of taking in this, I am going to take this whole area of this whole trapezium. Here, area of this trapezium, I think you know the area of trapezium. Area of trapezium. Area of trapezium formula is half into base into h1 plus h2. These are the two parallel heights. This is the height and this is the h1 and h2 of the equation. Here s is equals to, I told that if you find area, that's the displacement. So s is equals to half into, here base is t, into t, and h1 is u plus h2 is v. Here we get finally s is equals to t into v plus u plus v. This is u plus v by 2. Here we have got only one t, so let's make simpler to substitute the t value. 2s is equals to t into u plus v. Here we know that t value is t is equals to v minus u by a. I'm going to write here t is equals to v minus u by a. We are going to substitute this equation here. Here 2s is equals to v minus u by a into v plus u. Here it's like a plus b into a minus b formula, so we get 2s is equals to v square minus u square by a. Finally we get v square minus u square is equals to 2as. This equation is also finally derived. Here these are the three equations that which we have derived are, first one is v is equals to u plus at, and second one s is equals to ut plus half at square, and this third one is v square minus u square is equals to 2as. I think you found something information or something new about these derivations. So if you found that, please like this video, share and subscribe to our channel, that's Study to IT. Have a great day.